The ocean covers more than 70% of our planet. But the part we know, the sunlight zone, is only the skin. Below 1,000 meters lies a world so alien that it might as well be another planet. A place without light, without warmth, without plants. A place where pressure crushes steel, and yet life thrives. Welcome to the deep sea. This is the largest habitat on Earth and also the least explored. We know more about the surface of Mars than we do about these depths. And what we have discovered down here doesn't just challenge biology, it breaks it. Creatures that live for centuries. Animals with no eyes, or too many. Predators that glow. Bodies that melt. Bones that dissolve. Rules of evolution that simply stop applying. Tonight, we are diving into the abyss to answer one question. Why does the deep sea break every rule of evolution? At nearly 11,000 meters in the Mariana Trench, pressure exceeds 1,100 atmospheres. By all known rules, life should not exist here. And yet it does. Fish with transparent skin. Microbes that consume rock. Creatures whose proteins fold differently just to survive pressure. These organisms don't just defy evolution. They redefine the physical limits of biology. The first rule: life needs sunlight. On land, evolution begins with a simple truth. No sunlight, no life. Plants capture solar energy. Animals eat plants. Predators eat animals. Every ecosystem depends on the sun, except the deep sea. Below 1,000 meters, sunlight vanishes completely. Photosynthesis is impossible. There are no plants, no algae, no forests. By evolutionary logic, this world should be dead. But it isn't. Instead, life down here runs on chemical energy. At hydrothermal vents, cracks in the ocean floor, superheated water rich in sulfur and methane pours into freezing darkness. And around these vents, entire ecosystems explode into life. Giant tube worms, blind crabs, heat-resistant bacteria. These organisms don't need sunlight. They use chemosynthesis, feeding on chemicals leaking from the Earth's crust. This is evolution rewriting its own origin story. Life here doesn't start with the sun. It starts with the planet itself. On land, survival often depends on precision. Miss a hunt, miss a step, miss a chance, and you die. In the deep sea, survival is often pure chance. Food falls from above like rain from another world. A dead fish, a whale carcass, organic snow drifting down for weeks. Entire ecosystems bloom and collapse based on random events. Evolution here adapts not to control, but to uncertainty. The third rule: eyes are essential. Vision dominates life on Earth. Predators hunt with sight. Prey escapes with sight. Bright colors attract mates. But in the deep sea, sight becomes optional. Some animals lose their eyes entirely. Others evolve massive, telescope-like eyes. Some have eyes that detect only one color, blue, the only light that travels far in water. And many creatures abandon vision altogether. Instead, they evolve bioluminescence. They create their own light. Anglerfish use glowing lures to attract prey. Dragonfish emit red light invisible to their victims. Jellyfish flash to confuse predators. In this world, light is no longer passive, it is weaponized. Evolution doesn't just adapt eyes here. It replaces them. When size stops mattering. On land, size is power. Bigger animals dominate food chains. Smaller ones hide or flee. In the deep sea, size becomes meaningless. Some predators are enormous, like the colossal squid. Others are tiny enough to fit on a fingernail. Both survive. Why? Because encounters are rare. A massive body requires energy. A tiny body requires patience. Both strategies work when food arrives unpredictably. Evolution does not favor giants or dwarfs here. It tolerates extremes. Predators are fast and strong. On the surface, predators chase prey. Speed equals survival. But in the deep sea, chasing wastes energy. So predators evolve a different strategy. They wait. Some fish have mouths larger than their entire bodies, expandable stomachs, needle-like teeth angled inward. When food finally appears, they consume it, no matter the size. The gulper eel can swallow prey larger than itself. The black swallower can eat fish twice its size. Down here, missing a meal can mean death. So evolution creates monsters built not for pursuit, but for opportunity. Bones provide structure. On land, skeletons are essential. Bones support weight. They protect organs. They anchor muscles. But in the crushing depths of the ocean, bones become a liability. At 4,000 meters, pressure exceeds 400 times atmospheric pressure. Airspaces collapse. Rigid structures snap. So evolution does something radical. It removes bones. Many deep-sea animals have soft, gelatinous bodies. Their muscles are weak. Their tissues are flexible. They don't fight the pressure. They become one with it. Creatures like the blobfish aren't failures of evolution. They are perfect solutions. Evolution down here favors surrender, not resistance. Evolution without enemies. On the surface, evolution is driven by competition. Predators chase prey. Prey evolve defenses. An endless arms race. But in the deep sea, enemies are rare. Many species live in near-total isolation. Some may encounter a predator only once in their entire lifetime. Without constant threat, evolution takes a strange turn. Bright colors disappear. Armor vanishes. Speed becomes unnecessary. Some deep-sea animals have fragile bodies that would never survive on land, or even in shallow water. But here, fragility is safe. When there is no one to hunt you, evolution doesn't sharpen claws. It lets them rust. Immortality through slowness. Most surface animals burn brightly and die young. High metabolism, rapid growth, short lives. In the deep sea, time itself slows down. Cold temperatures reduce chemical reactions. Low oxygen limits energy use. Some organisms barely age. Certain deep-sea corals are over 4,000 years old, older than the pyramids. Sponges living today may have been alive when humans first learned to write. Evolution here does not rush. It waits. When pain and fear disappear, fear is a powerful evolutionary tool. Keeps animals alive. But what happens when threats are almost non-existent? Some deep-sea species show little to no stress response. They drift. They float. They endure damage that would kill surface animals. In an environment where danger is rare and escape is impossible, fear becomes useless. Evolution doesn't reward panic here. It rewards endurance. Reproduction requires proximity. On land, animals find mates through sight, sound, or scent. In the deep sea, individuals may never encounter another of their species. So evolution does something extreme. Male anglerfish fuse permanently to females. They become living sperm banks, losing eyes, organs, and independence. Some species reproduce asexually. Others release millions of eggs, hoping a few survive. Here, reproduction is not romantic. It is ruthless. Evolution prioritizes certainty over choice. Evolution favors efficiency. On the surface, evolution rewards efficiency. Fast animals survive. Strong animals dominate. Complex brains give an advantage. But in the deep sea, food is incredibly rare. A single dead whale can feed an ecosystem for decades. Most creatures may only eat a few times a year. So instead of speed, evolution favors patience. Some deep-sea animals move so slowly that algae grows on them. Others can survive months or years without food. The Greenland shark can live over 400 years, growing just 1 centimeter per year. It reaches sexual maturity at over 150 years old. By surface standards, this makes no sense. But in the deep sea, energy is everything. Fast metabolism equals death. Here, evolution favors slowness, longevity, and efficiency beyond imagination. Extinction means nothing here. Mass extinctions reshaped life on land. Asteroids, volcanoes, ice ages. But the deep sea barely noticed. While dinosaurs vanished, deep sea species continued as they always had. This makes the deep sea a biological time capsule, a living archive of Earth's past. Some creatures down here may resemble the earliest animals to ever exist. Evolution doesn't erase here, preserves. Evolution that defies death. In the deep sea, death is not the end. When a whale dies and sinks, it becomes a whale fall. An entire ecosystem forms around it. Bacteria, worms, crustaceans. Life feeds on death for decades. Evolution here doesn't avoid decay. It is built upon it. Change is slow. On the surface, evolution unfolds over millions of years. But the deep sea is a museum of time. Some species have remained unchanged for hundreds of millions of years. Coelacanth, horseshoe crabs, certain deep sea sharks. Why? Because the deep sea is stable. No seasons, no weather, no climate shifts. When the environment doesn't change, neither does life. Evolution slows or stops entirely. The deep sea and alien life. Scientists studying Europa and Enceladus, icy moons with subsurface oceans, look to the deep sea for answers. No sunlight, extreme pressure, chemical energy. If life exists beyond Earth, it may look nothing like us. It may look like this. The deep sea is not just Earth's strangest ecosystem. It may be a preview of life across the universe. Humanity versus the abyss. For most of our history, the deep sea was untouchable. Even today, only a handful of humans have visited its deepest point. And yet, we are changing it. Deep sea mining, plastic pollution, chemical runoff. Species that survived millions of years may vanish before we even name them. Evolution in the deep sea is slow. Destruction is not. Evolution without mercy. The deep sea teaches us a brutal truth. Evolution is not kind. It is not fair. It is not logical. It adapts life to suffering and calls it success. Down here, survival looks like monsters, like darkness, like patience beyond comprehension. The deep sea doesn't break the rules of evolution. It reveals them, and what it reveals is terrifying.